Mobile phone charger by Abhisar. A charger is a device used for charging or recharging batteries. A charger uses mainly four things: a transformer, a full wave rectifier, a filter, and a regulator. Transformer. Here is transformer in a circuit. A transformer is a device which takes in AC current at high voltage and gives output at a low voltage, or vice versa. As the device gets charged only at a particular voltage, the transformer, step down, is used to bring our AC 220 volt supply to a suitable, say 30 volt supply. A transformer changes input voltage to desired voltage. It does so as follows. The current in primary coil creates a flux in secondary coil. The change in flux induces an EMF. As shown by the formula, as the total power must be constant for an ideal transformer, the ratio of input voltage and output voltage depends on ratio of turns in primary coil and secondary coils. Hence, by adjusting the number of turns in primary and secondary coil, we can adjust the output voltage. Now, what is a rectifier? A rectifier is a circuit which converts AC to DC. A full wave rectifier uses only half of the input currents, hence, it is often not used. We generally use a full wave rectifier to convert our AC to DC. Here is our rectifier in the circuit. Now, we have two types of full wave rectifier: center tap full wave rectifier and bridge rectifier. Center tap full wave rectifier. A center tap full wave rectifier is a type of rectifier which uses center tap transformer and two diodes to convert the complete AC signal into DC signal. The center tap full wave rectifier is made up of an AC source, a center tap transformer, two diodes, and a load resistor. The AC source is connected to primary winding of the center tap transformer. A center tap additional wire is connected at the exact middle of the secondary winding and divides the input voltage into two parts. The upper part of the secondary winding is connected to diode D1 and the lower part of the secondary winding is connected to diode D2. Both diode D1 and D2 are connected to common load RL with the help of a center tap transformer. The center tap is generally considered as the ground point or the zero voltage reference point. So what happens is that in case because of change in flux, the EMF induced in this direction, the current flows and it moves like this and this. This point is grounded, hence the current always moves like this. Due to this, the current in the resistor flows like this. When the EMF is induced in this direction, we see that current moves like this, and this. So in any of the cycles, whether the EMF is induced in this direction or in this direction, the current always flows in this direction through our load resistor. Hence, it converts AC to DC. What happens is that this is the AC current and this is the DC current that we receive from a rectifier, full wave rectifier. Now, the other type of rectifier that we have is bridge rectifier. The bridge rectifier circuit is made up of four diodes: D1, D2, D3, and D4, and a load resistor RL. The four diodes are connected in a closed loop configuration to efficiently convert the alternating current AC into direct current DC. The main advantage of this configuration is the absence of expensive center tap transformer. Therefore, the size and cost are reduced. So what happens over there is because diodes allow flow of current only in one direction, when the current flows, it moves through the diode and this and from D to C and then this and this. In case the current is originating in this direction, what we see is that it again moves this and again the current flows from D to C and like this. So in either of the cases, the current always moves from D to C, hence this also allows conversion of AC to DC. So the if the input voltage is like this, we get the output voltage like this, a DC output. Now we have a filter also in a in our circuit. We also have the filter. The output that we get from rectifier is not stable. Hence, we use filter, which mainly consists of capacitors to convert very fluctuating voltage from rectifier to relatively smoother voltage, as I've shown in the diagram. Regulator. Even after filtering the output voltage, it is not absolutely steady. Hence, to provide a stable voltage, we use a regulator. Generally, a simple Zener diode based regulator is used, which contains a fixed voltage when it is in reverse bias. So, whenever the input voltage changes, the current through Zener diode also changes inversely, so that our output can remain constant. Here is Zener diode in our circuit. So this is the simplified version of the final circuit and explains exactly how our charger works. The transformer brings the high input voltage to a lower voltage required by a device. Because the device requires DC, the rectifier converts this current to DC. A filter, a filter and regulator help in smoothing the fluctuating DC into a steady current, and hence we can use this. And this is how our charger works. Thank you. Here are all the resources that I use for making this.